So how do we find an orthonormal basis? Well, remember that we have a vector space V. That's an inner product space. And we came up with a basis, V1, V2 to Vn. Now this basis might be given to you in a homework problem, or you might just come up with a basis for your vector space. And we want to find a basis B hat, which is U1, U2 to Un, such that Ui with Uj, the inner product, is equal to delta Ij. So to find the first vector is actually really easy. You just take V1 and divide it by its length. So that is a unit vector in the direction of V1. And since it's a unit vector, the length of U1 is equal to 1, which recall is the square root of U1 with U1. So if you square both sides, you get that the inner product of U1 with U1 is equal to 1. So we satisfied the first condition, Ui with Ui is equal to 1, with this first vector, U1. So that's going to be our vector U1, and now we need to figure out the rest of the vectors. So the first one's really easy to figure out. The rest of them are harder, and it gets harder the further we go along. So what I'm going to do is I'm going to show you how to find U2 and U3, and then I'm going to give you a formula to figure out the rest based off of the work we do. Okay, so let's try to figure out what U2 is. Now, to do this, notice that to figure out U1, I only involved vector V1. So to figure out U2, because it needs to be orthogonal to U1, I'm going to need to involve these two vectors. So it would make sense that I only involve these two vectors from the original basis, and that's what I'm going to do. Now I need to come up with a vector, and I'm going to call the vector Z1. I need to find a vector Z1 that's some linear combination of these vectors that is orthogonal to U1. And then I'm going to divide by its length, and that's going to be U2. So what I'm going to do is I'm going to find a vector Z1, and I'm going to divide by its length. You can write it in this form if you like. Maybe that one's a little bit nicer. Let me write it like that, if that makes more sense to you. So I need to figure out what this Z1 is. And I'm going to tell you what the Z1 is. So Z1 is a linear combination of V1 and V2. I'm going to call it Z for now, and then I'm going to rename it Z1, and you'll see why in just a second. So let's say we have this vector Z, and it's some linear combination of V1 and V2. So I want this vector Z, and I want to have that the inner product of U1 with Z is equal to 0, and then I want to divide Z by its length, and that's how I'm going to get U2. First thing to notice is that this C2 here cannot equal 0. The reason for that is if it was equal to 0, then this would go away because I'd have 0 times a vector, which is the 0 vector, and then I'd have Z is linearly dependent on V1. And I'm trying to come up with a basis, U1, U2, and so on, and remember that a basis is not linearly dependent. And since U1 is linearly dependent on V1, because it's just a linear combination of V1, and if I had the vector Z being a linear combination of V1, and then I divide by its length, and I call that U2, then U1 and U2 are both linear combinations of V1, and so then they're not going to form a basis. So there's no way that this C2 can be 0. And what I want to do now is I actually want to get rid of this C2. I'm going to divide everything by C2. Okay? And this is what I'm going to label Z1. So Z1 is just a vector divided by a constant that's not equal to 0. So I just don't want that C2 here, and there's reasons for that. You'll see in a minute. It makes life a lot easier. Okay, so I got rid of this constant here, now I have a 1. I want to do one more thing. I want to change this constant. I want to rename it. And what I'm going to do is I'm actually going to get rid of this V1. Notice that U1 is a linear combination of V1, but I can multiply, because this is a non-zero number, I can multiply both sides by the length of V1. And I can use that and substitute it right here. And so Z1 is C1 over C2 times the length of V1 times U1 plus V2. Okay, and now I'm going to call this big constant here, I'm just going to label it C. So Z1 is going to be C times U1 plus V2. And that's what I want to focus on. So what I'm going to do now is I'm going to erase all this for a second. And I'll just, Okay. And now let's move this up here. So this is our Z1. Actually, I'm going to move it here. This is our Z1, and Z2 is going to, we're just going to take the length of Z1 and multiply it by Z1, 1 over the length, multiply it by Z1, and that'll be U2. And I want to force that the inner product of Z1 with U1 is equal to 0. So it's obvious that the inner product, by this definition, this is a unit vector, the inner product of U2 with U2 is going to be 1. But I want that the inner product of U1 with U2 is going to be 0. And U1, the inner product of U1 with U2, is a scalar times Z1. We want that to be 0. We can take the scalar out. And so we need the inner product of U1 with Z1 to be 0. Okay, so let's actually take the inner product of U1 with Z1 and then see what C has to be in order for this to equal 0. Okay. All right, so computer wanted to restart. So the inner product of U1 with Z1 is equal to the inner product of U1 with CU1 plus V2, which is equal to, well, this is a linear inner product. So CU1 U1 plus U1 with V2. And remember, the way we defined U1 is that the length of U1 is 1, so this is just equal to C times 1, or C, plus the inner product of U1 with V2. And we want that to equal 0, so now we can solve for C. C is just a negative of U1 with V2, okay? Great. So now we can actually define U2. U2 is 1 over the length of Z1 times Z1 where let me get this. Let's move it up here. Where z1 is equal to u1 with v1, the negative of it, times u1 plus v2. Because we defined z1 as c times u1 plus v2. So z1 is v2 subtract the inner product of u1 with v2 times u1. That's how you're going to figure out u2. All right, now I'm going to do u3 a little bit quicker, and then we'll come up with the formula for any uk. All right, so the idea for u3 is we're going to take a vector z2 and divide it by its length. We need to figure out what z2 is. z2 is going to be, well, since u3 there's u1, u2, u3, it should be some kind of combination of v1, v2, v3. And this is going to be very similar to what I did a few minutes ago. This is going to be a c1 times a u1 plus a c2 times a u2 plus this vector v3. Remember when I defined z1, it was a c times u1 plus a v2. Well, now it's c1 u1 plus c2 u2 plus a v3. And to figure out what c1 and c2 are, well, I need the inner product of u1 with u3 to be 0. I need the inner product of u2 with u3 to be 0. So let's take the inner product of u1 with z2, because u3 is just a linear combination of z2, so I can pull that out. And I want u1 with z2, I want that inner product to be 0. And I want the inner product of u2 with z3 to be 0. So let's actually calculate these inner products. Okay? So the inner product of u1 with z2 is the inner product of u1 c1 u1 plus c2 u2 plus v3, which is equal to c1 u1 u1 plus c2 u1 u2 plus u1 with v3. The inner product of u1 with u1 is 1, so this is now c1, and we want this to equal 0. But we have the inner product of u1 and u2, and the inner product of u1 and u2 is 0, so this just becomes 0. So c1 plus u1 v3, which tells me c1 is negative u1 with v3. So that goes here. And then we need to figure out what c2 is, what this constant is. And we're going to do that by taking the inner product of u2 with c2. So if I take the inner product of u2 with z2, it's going to be very similar to this. It's going to be c1 u2 with u1. I'm just, instead of putting a u1 here, I'm putting u2. So everywhere I see a u1 on the left, I substitute with a u2. plus C2 U2 U2 plus U2 with V3. Again, because the inner product of U1 and U2 is 0, this becomes 0, and this is 1, so I'm left with, now I want this thing to equal 0, so 0 is equal to C2 plus U2 with V3, which tells me that C2 is equal to negative U2 with V3. So that's the other constant I want. And I plug it in to here, and I look at the relationship with this one. These are both negative. You see negative and a negative, and I have a positive V3. So that tells me that Z2 is V3 minus the inner product of U1 with V1, U1 with V3 times U1, subtract the inner product of U2 with V3 times U2. And this is going to be the formula for Z2. And then I just, when I figure this out, I divide by the length. Okay? So maybe you can figure out what U4 is going to be. U4 is going to be 1 over the length of Z3 times Z3, where Z3 is going to be V4 minus the inner product of U1 with V4 times U1 minus the inner product of U2 with V4 times U2 minus the inner product of U3 times V4 times U3, and then you're going, and that'll be it, yeah. So let's write a complete formula. So let me move down here so we don't have to see all that. So we're going to say that in summary, if we have a basis V1, V2 through Vn, then we have this orthonormal basis B hat, which is U1 through Un, where, I'm going to put this in red, U1 is just going to be 1 over the length of V1 times V1, and UK for K greater than or equal to 2 is going to be 1 over the length of ZK minus 1 times ZK minus 1, where ZK minus 1 is VK minus the inner product of U1 with VK times U1 minus the inner product of U2 with VK times U2 minus ... minus the inner product of UK minus 1 with VK times UK minus 1. And you can write this in summation notation if you prefer. You can say ZK minus 1 is equal to VK, subtract the sum. I is 1 to K minus 1 of UI with VK UI. Yeah, so that's a lot of stuff. So these two pieces and this piece will give you the orthonormal basis for your vector space V.